All right, today we're talking about standard deviation and really some other measures of variation as well. So here's three big ones we're going to talk about. Range. Range, pretty straightforward. Just how far apart biggest and smallest values are. Okay, so you just subtract max from the min. Or min from the max, I guess I should say. Interquartile range. Okay, we abbreviate that IQR. That is Q3 minus Q1. So remember last lesson where you did box plots, box and whisker plots, you found Q3 and Q1. So you just subtract those. That's the IQR. That tells you the difference between the middle 50% of your data. Pretty easy to find. Okay, now standard deviation you hear a lot, and it's a big one. It's a pain to find by hand. It really is. The lesson's going to take you through and show you the process. But we can just use calculators, Desmos, there's different tools online if we need to find standard deviation of something. I really just want you to understand what it means, okay? So it's a measure how much the values in a data set vary from the mean, okay? Basically how spread out the data is. All right, let's look at a little example. Excuse me. 17 women qualified for a ski team. Their ages were the following. So here's 17 ages. Find the range and IQR. Now, again, for time's sake, I already listed these from smallest to biggest, just like we did last lesson. So list your data set out, and then find the range. Well, that's pretty straightforward. My max minus my min. So it's just 30 minus 16. Of course, that'd be 14 years is the range from oldest to youngest. Now, IQR. Well, you need Q3, you need Q1. That's why I put them in order. I found the median, and then I found the middle of the lower half of data, and that was 19 here. Now this was an odd number, and so I left the 21 here and found out of these 10 numbers, what's the middle number? Or I'm sorry, out of these 9 numbers, what's the middle number? And then same thing here for the top half, okay? So I got my Q3, Q1, and then I just subtract them, 24 minus 19, hey, that's how you find IQR. Not too bad. All right, come back to standard deviation. How much the data varies from the mean. Now, here's a basic thing I'd like you to feel good about. Larger the standard deviation, the more spread out the data is. That's a basic thing, but that's really what I want you to know about it, okay? Given a mean of 7.6, standard deviation of 3.1, within how many standard deviations do all these values fall? Well, let's just kind of list this out. So here's 7.6. It's the middle, right, or the average. If we added one standard deviation this way, 7.6 plus 3.1, that'd put me at 10.7. So that'd be one standard deviation up. Well, what if I went down one standard deviation? 7.6 minus 3.1, so I'd have 4.5. So all of these values, everything from 4.5 to 10.7 is within one standard deviation of the mean. Half is above, half's below. You could go down another one, you could go up another one. So let's look. If I keep going now, 10, well 10's within 1, 9's within 1, 11, oh 11's out here, right? 11 would be a little farther. So it's within 2 standard deviations. 5 fits within 1. 3 is over here. So it's 2 as well. So what are they asking? Within how many do the values fall? Well, overall, 2 standard deviations, all of that data would fit within. Okay, so if you run into a question like that, that's all they want you to do. Okay, Z-score, last thing I want to talk about. Z-score shows how many standard deviations you are from the mean. So we just have a little relationship for it. You take the value of the data set, whatever value you're looking at, minus the mean, divide it by the standard deviation. That gives you a Z-score. Okay? So the smaller the Z-score, the closer that value is to the mean. A Z-score of 0 would be right dead average. So given a mean of 7.6, standard deviation of 3.1, what's the Z-score of the value 5? So let's just plug things in, okay? So 5, that's my value, minus the mean, so 7.6, over the standard deviation, 3.1. So 5 minus 7.6, that'd be negative 2.6 over 3.1. Now what the negative means is it's below the average, okay? Now let me just bring my calculator up so we can go ahead and plug that in. So we've got negative 2.6 divided by 3.1. And so that's a z-score of about negative 0.8. Where's my pen at? There it is. Negative 0.8. So what that tells you, it's a little bit less, or it's not quite one standard deviation below the mean. So it just takes it and it tells you where things are located, how many standard deviations from the mean, all right? So those are kind of the big ideas from the lesson. They're going to have you go through a bunch of examples and do things, but hopefully that'll kind of help get you started. Keep a calculator handy, go through these things. Hopefully makes sense to you.